Hi everyone, it's Benoit Petit again to talk about SLOs and climate change and how we can continuously reduce the climate impact of tech services with SLOs. So this is part two. If you are interested in the roots of that talk and the theory part regarding the impact of the tech industry on climate, please jump on part one. If you have already seen it, let's do it. So why is SRE really interesting regarding the sustainability question of tech services? First, I wanted to highlight some principles that we find not only in the SRE methodology, but also in the DevOps mindset that are really interesting and I think should really be applied to the sustainability question of our services. The first one is change is necessary to improve. So that may seem obvious to a skilled SRE, for example, but that's really the opposite mindset that we find most of the time when we talk about reducing the impact of digital services on climate and about any action that we should do regarding climate change, actually. The second one is breaking down silos. So most of the time in SRE and DevOps, it's about collaboration between teams. I think that principle is great and should be extended to a larger scale. When we talk about carbon footprint, for example, when we want to calculate the carbon footprint of an organization, we really have to collaborate and exchange with partners, vendors, and suppliers when they provide a good or a service. They are also emitting carbon. So we couldn't have the full picture with only calculating our own carbon emissions. So collaboration with other organizations and sharing knowledge regarding that topic is really, really important. The third item is the no blame culture or blameless culture. That's really interesting because when we talk about action for climate, it happens really often that people will do finger pointing at other teams, other people, other companies as an excuse to not move or change themselves. So we really have to avoid that behavior and work on collaborating together and learning in the way, learning from each other. So that's really, really interesting, really, really important. The fourth principle is small and frequent changes are better than big promises. A very simple example regarding that is reducing our carbon emissions right now, piece by piece, and learning on the way is way, way more efficient than big promises like we will offset our carbon emissions by planting trees, which is a huge promise as you don't know how much time the tree will live, if it will be cut or burned, when, and actually when you plant a tree, it takes decades to be big enough to have a real impact on climate. So we don't have decades, as you may have seen in the first part of this talk. So acting now, even if it's small action, getting bigger with time is way better than promising we will find a miraculous solution. Regarding SLOs, I really think it's the perfect toolbox to work on those topics with our digital services. Because it helps to define a common objective across teams, whether it's tech, product, or business. And the collaboration between those teams is, I think, key to have a significant impact to reduce our carbon emissions. Most of the time, it comes with tooling that enables to keep track of that objective. So that's also really, really interesting. And it drives focus and enables proactivity, which is also key. Another thing I wanted to highlight is that without SLOs, actually there is, I think, a double analogy between reliability of a system and its climate impact. Because when we don't have SLOs, regarding reliability, we don't have clear objectives, except if we have SLAs, but that's not true for all businesses. And when you don't have clear objectives, what happens most of the time is that people, they hope for the best. So people expect basically 100% of time uptime, 100% reliability, and that's about the same with climate. We don't have objectives at all regarding the climate impact of our services. And so people hope for the best. If you ask them about the climate impact of their service, they will say, hey, digital is clean, it has no impact. So we have seen the first part that one item on which we could act is the electricity consumption of our services and of data centers. But first, how are we emitting carbon emissions by consuming electricity? Like, electricity is somehow known to be a clean energy. So the explanation is that electricity is actually a final energy, which means it has been produced from another kind of energy, which we can call a primary energy. And primary energies are multiple. You maybe know them. It's like coal, oil, solar, the wind, the nuclear power. All those energies are primary energies, and we use them to produce the electricity we will consume in the data center. So this is not about electricity. This is about the energy that's been used to produce that electricity. So we need at least two informations to measure the climate impact of a digital service. First, what we have on the right, we need to know the power consumption of that service. And then we need also the carbon intensity. This is the part on the left, the carbon intensity of the electricity mix, the electricity network that allowed us to consume that electricity. So the carbon intensity, you guessed it, is linked to the primary energy that is used. And so how do you get those two informations? The first information, which is the power consumption, can be measured, for example, by Scaffold. Scaffold is an open source project we are working on at Hublot to measure the power consumption of a server and of the services and processes that are running on that server. So as I said, it's open source under an Apache 2 license, so every contribution is very, very welcome. It's written in Rust, and it already is able to talk with Prometheus, Warp 10, Riemann, and in the future with much more monitoring solutions. The second item is how to have the carbon intensity of the electricity we consume. You have a service that's called Electricity Map. That's an interactive map showing the carbon intensity by country or by state. So that's really a great tool. Part of it is also open source. You can contribute to the way the data are computed, are calculated, and aggregated for each country or each state. You see on the map that there are still some countries in gray. It means the data are not there yet, so you could help with that. They also have an API to get those data, which is called the Electricity Map API, and a second API that's kind of a simplified version of the first one, which is called CO2 Signal. So with that toolbox, you really have what's needed to have the carbon intensity of your electricity. So now that you have the tools to get the two informations you need, it could look like this to get the carbon intensity of, let's say, requests on an API. You could look at with your usual monitoring. You could look at the number of requests you have in 1 hour coming on your API or service. Then you take the power consumption of your API aggregated thanks to Scaffold in the first place. And then you compute a ratio, which gives you the power consumption by requests. And then you can apply the carbon intensity on that ratio, which gives you another ratio, which is the carbon intensity of each request. And that metric can help you build SLIs, of course, and then SLOs. Then, of course, you have to define your error budget, but this is the basics that you could use for that. So thank you very much for watching this video. I may post a third video, part 3, about a demonstration regarding Scaffold and monitoring of the power consumption. I'm not sure if I will have time to do it. So if you don't find it during the SLOconf, just reach me on Slack, on Slack of the SLO conference, or reach me on Twitter or by email or anything, and I will be able to show you how it works and give you an overview of it. So thank you very much and have a great conference, and see you around.